Okay, so in this problem, we're going to be finding displacements and stresses. Now, the first thing we do is count our elements. Element 1 is represented right here. Element 2 is represented here. Element 3 is represented here. Now, next thing we need to do is our count of our equations. Now, if we look here, we have a force in the x and a force in the y. So that's these guys. And here we have the exact same thing. We have a force in the x and a force in the y. And so forth here. And then back to 1. Okay, so we have a total of 8 equations. So what does that mean? That means that we have an 8 by 8 matrix. So before we even start the problem, we know the size of this matrix. So that's pretty important. Next thing we want to do is take our local element matrix. We want to add them up and come up with a global element matrix. This is our global element matrix down here. So we're going to go from our local element matrix to our global element matrix. So the first thing we do is we start at node 2, which is right here. And if you notice, this is force 2 in the x, so that would be this guy, right? And this would be force 2 in the y, so that would be this guy. Just for some reference there. So let's start here at node 2. We're going to go like this. Okay, so the first thing we put into our matrix, we're going to take this block and we're going to put it into our matrix right here. So that's our first value we put in. Okay, so now we move on to node 1, so that's right here. Okay, so we are done with element 1. We finished element 1 here. Let's move on to element 2, which is right here. Now, we're going to be focused on node 3, which is here. Now, back to node 1. So we're done with element 2. Let's move on to element 3. Okay, we are done with element 3. Now, next thing we need to do is put in zeros where you're missing places. So that would be here. The textbook likes to use lambdas, and that's what this is right here. So, in these textbooks, you'll see this a lot. This is lambda top left, that is represented here. Lambda top right is represented here, bottom left, and then bottom right. So it's a more simplistic way to write things. For instance, take lambda top right, and I can represent that as, so it's a more simplistic way to write things. And once you get into more complicated problems, sometimes it's easier to do it that way. But it's all about your preference. Successfully added up our global element matrix. This represents this entire system right here. Next thing we do is boundary conditions. If you look at node 2, node 2 is not going to move up. It's not going to move up or to the right. So it's 0. If you look at node 3 is also fixed to the wall, pinned to the wall. So it cannot move this direction or this direction. So it's both of them are 0. Node 4 cannot move this direction or this direction. So they are both 0. So all of these are 0. So go ahead and plug in your values right here. Okay, so we are done with our boundary conditions. Now next thing I'm going to do is zero out the columns. If I look here, if I were to work out force 1 in the X, which is represented right here, I would work it out like this. Okay, so you can kind of see the pattern here. This is associated with this column. This is associated with this column. This goes with this column. And then so forth. Would all be zeros till the end. This last one would be associated with this column. So what I'm going to do is I'm going to take this 0 and I'm going to multiply it here. And I'm going to do that with all the rest. So that's what I got here. I got all zeros. Next thing we need to do is move our unknowns to the right hand side of the equation. If you look at the problem here, I don't know this value or this one. I don't know those values. Same thing is true here. The same here. Since there's a force in the y, there's no force in the x here. So we're gonna go ahead and say that the force in the x is 0. What we want to do, go ahead and put that value in here. So put a 0 in there. Okay, so our unknowns are these guys. These need to come to the other side of the equation. Well, I can start with this one first. I can move this one to the other side of the equation. So how do I do that? Well, I would look at this equation in total, right? This is represented right here in the x direction. And I could work it out like this. You can see that I brought this to the other side of the equation here. And that's where that negative comes from. So I can go ahead and do the same with the rest. I'm going to take the rest of these guys and move them to the other side of the equation here. And that's what I get here. Okay, so the goal is to get all of our unknowns on this side and all our known values over here. Now, if you look on this side, we have negatives right here. We don't want these negatives because that'll give us a reverse answer in the calculator. So go ahead and distribute the negatives out. So that's what I did here. So you can see I distributed that negative out. And of course this would be associated here, and so forth. Next thing I want to do is I want to come up with our system of equations here. I'm not going to work all these out, but I'll work the top one out here. So if I were to work out this guy, which is represented force 1 in the x direction, I would work it out like this. Okay, so you can see that when I work out this top guy right here, I get this equation. And you can do that with all of these, the rest of these. And you'll get all these system of equations right here. Okay, so now we have our global element matrix. If you look here, we have all of our unknowns over here, and we have all our known values here. Now, what is F in the Y? Well, that's right here. We know this value, 50 kilonewtons. K1, we have K1. K1 is right here. K1 is represented by this element right here. K2. K2 is right here. K2 is represented by this element. And we also have K3, which is represented here by this guy. So we also have C equals cosine theta and S equals sine theta. So we know everything here. Now, here's how you work this out. So if you notice, I have a little table down here. Let's start with element 1. Element 1 is represented here. So what you're gonna want to do is you're gonna want to take your element. You're gonna want to draw a line through it like this, and then we're gonna go ahead and get this angle right here. Okay, you can see that this angle is 135 degrees for element 1. Let's move on to element 2, right here. And element 3 is the last one. Okay, so now we have our global element matrix. If you look at this, we have all of our unknowns on this side, and we have all our known values here. So what is Fy in the 1? Well, that's this right here, 50,000 newtons. We know that value. K1. Well, K1 is represented here. We know that value. It's right here. K2 is represented here, and we know what that value is. We've worked that out. And of course K3 is right here. So we have K3 as well. And the other thing we need to know here is C equals cosine theta and S equals sine theta. So if you notice, I did a little table down here. So here's how this works. We're going to start with element 1. Element 1 is represented here. First thing you want to do is you want to draw a line through it, and then we're going to find the angle here. Okay, you can see that element 1 is 135 degrees. Now let's move on to element 2. Element 2 is right here. So it's going to be like this. And lastly, element 3. So we're going to do this guy. Okay, now that we've defined our angles, now we can go ahead and start working out the problem. C cosine theta of 90 is 0. And then sine theta of 180 is 0. So this is a good place to start here. So we want to start filling in our values here. The first thing we're going to do is we're going to look for a CK3. So let's find all the CK3s. So we'll go ahead and put in our zeros where we need them. So we'll do it like this. Now, the next thing I like to do is I like to move on to element 2 for SK2. Okay, now I can just plug in the zeros. Now that we've simplified it, put in our zeros, now we can go ahead and put in the rest of these values into the matrix. Okay, so last thing we have to do is find our stresses. So if you look at this problem right here, element 1. Element 1 is represented right here. Now if you notice, I'm going from 2 to 1. So I'm going from 2 to 1. So you can see that this element is in this direction. So that's why I went ahead and drew this arrow right here. Now, the next thing I need to notice here is we already know that in our boundary conditions, we know that this is 0. So this is 0. So from here, right, we're going to go here. So go ahead and put in your zeros here. Now, next thing we do, now we've come up with this, right? And you can see that whenever you put in, 135 degrees for this element 1, you can see that you'll get an answer of this guy. Now, this answer right here represents this arrow. But the next thing I want to point out is, now we got a negative answer here, right? So we automatically know from mechanics and materials that this isn't compression. So we got compression as an answer here, but we have a negative here. So we need to go ahead and reverse the negative. So go ahead and do that right here. So we're gonna take this arrow and we're gonna make it go the other direction. Okay, so that's what I did there. Whenever you do that, we go to tension right here. Okay, so you can see that this right here is in tension. So that's all there really is to it. You got to pay attention to your directions, and then you can move on to element 2, right, which is right here. And you can see that this element is going in this direction. So this element right here is going in this direction. So it's this direction right here. So as long as you pay attention to your directions, you should get the right answers here. So when you solve this, you get this guy.